solutions, polar, non-polar molecules. In a liquid, these solvents consisting of polar molecules are called polar liquid. An excellent example of polar liquid is water. Polar liquid readily forms solutions with other polar molecules. Those molecules with evenly distributed charge from non-polar liquids. Non-polar solvents readily form solutions only with non-polar liquids. So the best example for polar liquid is water, and always polar liquids readily form solutions with other polar molecules, and in the similar fashion, non-polar molecules readily form solutions with non-polar liquids. This concept explains several everyday phenomena. We all know that oil and water do not mix, and they form separate layers when they are put together in the same container. Gasoline and oil float on top of water because gasoline is a non-polar liquid and oil is a non-polar liquid and water is a polar liquid. So polar dissolves only polar, non-polar dissolves only non-polar. That is the very reason oil and gasoline they float on top of water. They do not mix with each other. Applications of polar molecules. From what we have seen, greasy dirt is not soluble in water. Since grease is formed from nonpolar molecules, so we know that the greasy dirt, whenever we try to wash the grease with the water by itself, it is not going to go off because the grease is a nonpolar, which is oilless material is a nonpolar material. In order to use a water-based solution to clean greasy items, a special kind of molecule is used as an ingredient in soaps and detergents. These specially formed molecules surround the dirt particles so that the large clump called micelle, which is a polar molecule, becomes soluble in water. So the head and tail parts of the non-polar liquid, so they try to capture the dirt and they try to capture the dirt away from the hand. That way the hand will be dirt free when we wash with the water. That ingredient is mixed in soaps and detergents. Dissociation of polar molecules. Dissociation is a term given to the separation of a compound into ions when it is dissolved in a solvent. So just the separation of materials into ions is called the dissociation. And this is what we mean when we say dissolve. These ionic substances are called electrolytes. Since they consist of freely moving ions, any ionic substance that dissolves in water is called electrolyte. So again, any substance, any ionic substance that dissolves in water is called electrolyte. Here, when an ionic compound is dissociated in solvent, both negative and positive ions are present. A solution with only negative or positive ions is not possible. When two ionic solutions are mixed together, new ionic compound can be formed. For example, when a solution of silver nitrate is mixed with solution of sodium chloride, a precipitate, because whenever this is mixed together, so the precipitate is an insoluble solid, and the result is an aqueous solution of sodium ions and nitrate ions with solid a silver chloride which is insoluble in the solvent. You can see this picture right here. The silver nitrate solution is poured in here and sodium chloride solution is poured in here. When these two are poured in this one, all these four, all these two solutions are going to be broken down into ions as silver plus, nitrate ion, sodium plus, and chlorine minus. In here, Sodium plus and NO3 minus ions remain in the solution, but the rest of the silver and chlorine they come together and they form a precipitate, and that is that white precipitate at the bottom. Arrhenius was the first scientist to propose that many substances became dissociated into separate ionic spaces when dissolved in water. At the time, there was no knowledge of ionic structure. His work contradicted with the work of other scientists, but was eventually accepted as more was learned about the atomic structure. Because water is an essential thing for life on this planet, many consider it the single most important liquid. The polarity of water makes it a great solvent. This means a variety of substances can be dissolved in water. So we talked about it earlier that water is the substance which could dissolve many other materials compared to any other solvent. The living need of water. The living organisms depend on fresh water for drinking, farming, washing, even electrical energy production for us humans. Less than 1% of the total water on the earth is easily usable by humans for consumption. So you can see that most of the other water we have to purify or we cannot use them for regular consumption. So the world's water supply, most of the water comes from the oceans, which is 97% approximately, and then ice sheets, glaciers, groundwater, atmospheric water, lakes, seas, water lakes, soil moisture, and rivers. You can see that the maximum is from oceans, where we all know that it's mostly salt water, which you cannot consume for other humanly purposes. And the next is from this segment right here. As you can see, very little of water in existence on our planet is fresh water. The majority of the water has a salinity, which is about 3.5% in the ocean water, mostly a sodium chloride solution. The majority of the fresh water is trapped in a solid form at the polar ice caps. The largest single use of fresh water is in agriculture applications. As you can see that most of the water we want to use in the fresh water is used by the agriculture, then industry, then the domestic usages. As water seeps through the ground, it forms solution with the minerals in the ground. We all know that, like on top of the earth, we have many other materials, and this water flows from one place to other place. So when it does that, then it takes all the minerals in the ground and it flows through that. So when this water is mixed with a lot of other minerals, then it is referred as hard water. Soft water has few dissolved minerals, and the hard water is a direct result of the geographical landscape, which is the underground, combined with the superior performance of water as a solvent. Because of the superior solubility of water, many undesired solutes from solutions. This means water is polluted. So, since the water has a tendency to dissolve many other materials, so while it's flowing through the ground or on top of the ground, it also will be mixed with many other minerals. Yes, that makes the water either not usable for humans or, in other words, it is polluted. Sources of water pollution. There are two major contributions to the pollution levels in our freshwater resources. First one is industry, second one is agriculture. While these endeavors contribute to the overall improved quality of life, they can also be very destructive by introducing harmful substances into the atmosphere. Many of the substances readily from the solutions with water. One of the worst pollutants from industries we get is mercury. Several industrial processes result in the production of the waste products that contain mercury, and its chemical formula is Hg. While most mercury compounds are nonpolar, thus insoluble in water, they can be broken down into soluble compounds which could enter the food chain. In the news, fish containing mercury. One of the examples is the use of pesticides DDT, which is now banned in US. The pesticide was an effective agent in controlling insects that were harmful to crop production, but the DDT is also deadly for non-human, non-harmful animal life too. So when we are doing agriculture, in order to get the most out of the crop, we try to use the fertilizers, and these fertilizers are also the pesticides. They not only kill the bugs in the crop, but also they are harmful to the animals. The environmental effects of fertilizers use. Nitrogen, phosphorus, and potassium are used to enrich the plant life. So these are the ones which enrich the plant life. So they use it as fertilizers to make the best yield. However, when these fertilizer components are introduced into the freshwater resources, such as lakes, streams, and overgrowth of algae can occur. Increased algae means increased bacteria. This bacteria uses oxygen to break down the dead algae. When the bacteria use up too much of oxygen, other life, other life forms might die. Three classes of electrolytes: acids, bases, and salts.